Okay, this is how the story begins. We already know if we have 5 squared, then this is same as 5 times 5, and that is 25. And that operation is squaring, right? So it's 5 being raised to the second power, which we also call square. So that is squaring. We also have the reverse operation. Well, raising number to second power, it's an operation, right? Well, we do have the reverse operation, so we can go backwards. And that operation is called to take a square root. To take square root, we have to use this symbol that we call radical sign. And that's kind of like where everything being connected to our new topic, radical sign. So square root of 25 equals 5, right? So that's a couple notes. Once again, I'm sure you're aware of all that I just said, but that is radical sign. And that operation is taking a square root. Those two are reverse operations. Because when we have to take square root, we think this way. So if I have square root of 25, I'm thinking like over here. What number, when squared, gives me, what number when squared gives me 25? What number when squared gives me 25? Well, that's 5, right? And that's how we think about square roots. So if I, let's say, want to do square root of 49, then I'm thinking same way. What number when squared gives me 49? Well, that number is, what number is it, guys?
7?
7, that's right. Yes. Good job. So 7. And again, the way I check that is that 7 squared, which is 7 times 7 is 49. Okay, that works. Then let's say square root of 1 over 81. Now it's a square root of a fraction, but not a big deal because, well, I am thinking same way. What fraction when I multiply it by itself gives me 1 over 81. And remember, when we multiply fractions, we multiply numerators together and we multiply the denominators. So to get 1 in the numerator, I have to multiply 1 by 1, right? So it's 1 over, and then 1 over 9. Denominator is 9 because, again, 1 over 9 times 1 over 9 is 181. In other words, 1 over 9 squared is 181. How about, or actually, yeah, no, I'll just write like that. Square root of negative 25. Let's think about square root of negative 25. So what would be the answer? Or is there an answer? So I'm thinking some way, what number when I multiply it by itself, or square, in other words, gives me negative 25, right? And then I start thinking, well, I'm not going to use 5. I'm not going to say 5 because I know square root of 25 is 5, and I can check 5 times 5 is 25, right? Not negative 25. Then I'll think, well, maybe then it's negative 25. But if I try, or if I check, well, I'll write both. 5 squared is 25, right? Well, if I do negative 5 squared, that's negative 5 times negative 5, but then negative times negative gives me positive, right? So see how negative 5 does not work here as well? So that's not what I need, and that's not what I need. So, and I mean, it would be silly to try any other numbers, right? If I have 25, I know I wouldn't try 6 or 4. Since they don't work, we don't really have an answer here. And here's the deal. Yes, that's true that there is no such number like that, and we call those real numbers. So if I take a ruler or a number line, then I'm not going to find number on the number line anywhere that will work for the square root. And all the numbers that are sitting on the ruler or number line, right? Ruler is just kind of like real life application of the number line, but in math we just say number line. So all numbers that are living on the number line, they're called real numbers. So they kind of like exist in the real world. We use them in real life. there's no such number like that. So we'll say here, so I'm gonna erase that, an equal sign. I'll say is not a real number. And that's true, that will never change, so there is no real number answer to the square root of negative 25. But very soon, we're actually gonna learn that square root of negative 25, there is an answer to that, and it's not gonna be a real number, there is none. But it's called complex or imaginary number. So we'll go into that a little bit later. But for now, every time when we have to say take square root of a negative number, and that works same way for square root of negative 49 or square root of negative 81, square root of negative 100. So in other words, every time I have square root inside, every time I have negative number inside the square root, my answer will be, well, for now, it's not a real number. So that's the only answer I can provide. Now, right next to this example, square root of negative 25, which is not a real number, I'm going to write one more, and this time I'm going to write this way, negative square root of 25. Now, is it exactly the same problem or not? Well, obviously it's not. You can see how a negative sign is not inside the square root, not inside the radical, but outside. Okay, what does that mean? Well, that means that this time that negative sign, it's kind of like on its own, so it's in front of the square root, and as we can see, inside the square root is a positive number. So if we follow the operations, first we have to evaluate square root of 25, which we know is 5, right? So that means that, well, I'll write square root of 25 as 5, and that's from here. And then that negative sign that was in front, I'm going to also put in the front. So I'm going to carry it over to the next step and put it here. So in this case, answer is negative 5, but you see the difference, right? We have kind of negative sign and square root can be separated. So that's how we're going to look at the examples where we have negative signs present along with square root. So with negative sign being inside versus outside makes the difference. Great. Let's move on. Now, since we see that square root is the reverse operation of squaring, well, then we can expand this idea. And now we can say, well, I know that 2 to the third power is, well, it's 2 times 2 times 2. That's 8, right? And this operation is called cubing, or raising something to the third power. I will say cubing, same thing. That's because of the third power. Well, it means that we should have the reverse operation, and in this case, it's going to be also taking a root, but it's going to be cube root. So the cube root is written this way. So we have to write the radical sign, but then to distinguish cube root from the square root, we're going to put little index 3 right here, right? So that means that it's the reverse operation of the cubing. And this time I'm going to put 8. And the way I think about it, again, what number when I cube it gives me 8? Well, that's 2. So the way we think about that is the same. It's just the difference is squaring versus cubing, like that. Okay, so cube root of 8 is 2. How about cube root of negative 8? Remember, it was like a special situation with negatives, right? We had to be careful when we work with square roots. How about cube root? Cube root of negative 8. What do you think? Is there an answer to that, or we should say it's not a real number? So is there a number that such that when I cube it or multiply it by itself 3 times, I get negative 8?
Negative 2 on that one because it's 3 times, right?
Exactly. It's negative 2. So we were able to find the answer because that's how I'm going to check that. If I take negative 2 and raise it to the third power, which is negative 2 times negative 2 times negative 2. Well, the first pair of negative 2 and negative 2 gives me positive 4. But then when I take positive 4 and multiply it by negative 2, I get negative 8. And again, negative sign stays because we have 3 factors. Great. And we can actually generalize this, and we can say now that when we have cube root of a negative number, then we will get the answer, and that answer will be negative.